All right, so determine the equation in general form whose roots are 2, -4, and 1/3. So that means I know that x is equal to 2, x is equal to -4, and x is equal to 1/3. First thing we need to do is find our factors, so that's get this equal to 0. So we're going to move that 2 over this way. It's positive, it's crossing the equal mark, so we're going to minus it. So this factor is going to be x minus 2. Same thing for our -4. We're going to move it, add it to both sides because it's a negative to get it across the equal mark. So it means x plus 4. Now, this fraction, there are no fractions in your factoring, depending on how you want to do it. But 1/3, there's a 3 in the denominator, so I'm going to multiply both sides by 3, which gives me 3x equals 1. Now it looks just like the others, except we have a 3 attached to that x. I'm going to move that 1 over by subtracting. So that factor is going to be 3x minus 1. So 3x minus 1. Now I have all three factors. This is factored form. If they want it in general form, 9 times out of 10, they do not care that you can write it in factor form. They want you to actually continue going and push through, especially on your EOC questions. So you can do Black's method, you can do FOIL, you can do whichever way it makes sense for you to multiply these. So x minus 2, x plus 4. X times x gives me x squared. X times a -2 is a -2x. 4x, and then -8. That now gives me x squared plus 2x, because positive 4 minus 2x, or plus a negative is a positive 2x, minus 8. So I've now taken care of the first one and the second one, but I still need to take care of my 3x minus 1. So if we do box again, 3x minus 1. 3x times x squared is going to be 3x to the third power. 3x times 2x is going to be 6x squared. 3x times a -8 is going to be -24x. -1 times x squared is a -x squared. -1 times 2x is a -2x. -1 times a -8 is a +8. Now pull out and simplify. If everyone's not present, so 2, 1, none, 1, none, then these are not going to be perfect diagonals. So just make sure you're looking at what actually goes together and paying attention to your positive negatives. Highest exponent in the front, highest value exponent, and then simplify all the way through. Minus 26x plus 8. And this is the correct answer to that problem. All right, number 2, another released EOC question. What is the remainder when x cubed minus 1 is divided by x plus 2? So if it's divided by this, you could do long division if you want, but there's people missing. And all they're asking for is the remainder. So what is the leftover? So it's definitely not a factor, because there is a remainder. So if I can find out what x is equal to, so I say x plus 2 equals 0, move my 2, x is equal to a -2. You're going to plug that -2 in, and this is just simply using that remainder theorem, so it's going to go in the place of x, not -2 and x, actually in the place of x. So -2 times -2 is a +4 times -2 is a -8, minus 1, so our remainder is a -9. Determine k so that x minus 2 is a factor. That means it's going to be equal to 0. And then I need to know what this value of x is. So again, this x minus 2 equals 0. We're going to solve for x by moving that by adding 2. So x equals 2. And now we're going to rewrite our function because we have an x value, because what we're actually solving for at this point is that ugly k that's in the way right there. So we're going to take our +2 and plug it all the way in, all the way through. Law of PEMDAS, order of operations. You want to do your exponents first. So it's going to be 2 times 8 minus 3 times 4 plus 2 plus k is still equal to 0, and the 0 is because it said that it is a factor, is how you know that it is 0. If it had said that it had a remainder of another number, that's what would go there. So 2 times 8 is 16, minus 12 plus 2 plus k equals 0. 16 minus 12 is going to be 4 plus 2 is 6. A lot of people just say the answer is 6 because you want to skip the process and not have to write everything out. But be very careful, because this has to get away from k, which is making it into a -6 as it switches side. So our k value is -6. The graph of the function x cubed plus 3x squared minus 2x minus 4 has a 0 at -1. What are the other zeros of the function? So you could try -2 and 2, or actually it's a multiple choice question, so I would pick one of them. I would try +2. Is one way, if it happened to me, you didn't want to use your calculator. So it's 8 plus 12 minus 4 minus 4. It's a -8, so it's equal to 12. That means there is a remainder, so that means it is not a factor. Try -1 the same way, because again, if there is, and this is just me showing you something other than a calculator mathematics skill that will help you answer other questions, if there is a remainder, then it is not a factor. So that's going to be -1 plus 3 plus 2 minus 4. So -1, that's going to give you +2. 2 plus 2 minus 4 equals 0. It is 0. Other zeros, so you could check your 4 if you want to go through that math. So 4 cubed plus 3 times 4 squared minus 2 times 4 minus 4. 4 to the third power is 64 plus 16 times 3, 48 minus 8 minus 4. Definitely not going to be 0, so 4 does not work. So that's no good. Now, at this point, what I would do is turn those into decimals. So 1 plus 2 times the square root of 3, and that is 4.46. And then -1 plus the square root of 5 is 1.24 if you round appropriately. And then honestly, I would take this and put it into Desmos, your equation, and then go see where it crosses the x-axis or lack thereof of the x-axis, because it could be imaginary, but that would be the best way to get this done. And sorry, I can't split screen to show you that. So you definitely want to put it in Desmos. So go to Desmos, plug that equation, the x cubed plus 3x squared minus 2x minus 4, and go see where it crosses the x-axis, because your zeros are the same thing as roots, x-intercepts, and solutions. All right. Find m. So the 2x plus 3 is a factor. So again, is a factor means this is equal to 0. 2x plus 3, we have to solve for x. So we're going to move that 3 by subtracting it. And we end up with 2x equals a -3. Don't panic, but we have to divide by 2. So x is going to equal a -3/2. Now, my biggest call out would say, slow down, be careful, use your calculators. So 8 times a -3/2 to the fourth power minus 2 times a -3/2 to the third power plus 3 times a -3/2 squared plus m times a -3/2 plus 6. And it is equal to 0, and I just ran out of room. Now, you could also change that -3/2 to a -1.5. So a -1.5, which may be better for you as far as putting in your calculator, to the fourth power is a negative, so 8, -5.0625, and I'm just showing this to you all the way through, minus 2 times, what's going to be positive? I did exactly what I told y'all not to do. Make sure you use your parentheses. And then -1.5 to the third power is a -3.375 plus 3 times a -1.5 squared, which is 2.25. This guy just hangs on. I would write it as a -1.5 m plus 6. Now, your other option as far as putting this in your calculator is be really careful. Use your parentheses as you go through. So 8, -1.5 to the fourth power. Make sure you come down. Minus 2, parentheses, -1.5 to the third power. Plus 3, whoops, -1.5 squared. You can't put in your m. So plus 6. And remember, this is all equal to 0. So right now I have a -1.5 m. And what we're looking for is this right here. Hit enter. It's going to be 60. when we put all that together so it looks all nasty, but it's a matter of making sure you use your parentheses, go slowly enough, and put everything in correctly. At this point, I need to solve for m. So I'm going to move my 60 to the other side by subtracting it, and I have a negative 1.5m equals a negative 60. Divide by negative 1.5 m. Negative 1.5, not m. We want m to stay by itself. So we're trying to get it by itself. So 60 divided by 1.5, but we know it's a negative. So our answer is going to be negative 40. Oh, negative, so it's a positive 40. Positive 40. So m is equal to a positive 40. This one, the difference is that it is attached to an x value. It's not the last term in the polynomial. And you just have to stay the course. Remainder theorem should be something that's fairly easy, though. But you can't really go graph it and answer this question. All right, so again, this is one of those ones that you were probably, for your best answer, going to graph it in Desmos again. So 2x to the 5th power minus 13x to the 4th plus 22x to the 3rd minus 187x squared minus 160x plus 336. Because in case you can't see it because it's a little gray. Now it says that I have a 0 at x minus 7 and I have a 0 at x plus 4i, or it actually says that they are factors. Those are the factors. If I solved it, they would be zeros, like set them equal to 0. What is the total number of real zeros? Real zeros is where it crosses the x-axis. So if I put this into Desmos, I'm going to see where it touches the x-axis. But also, knowing that it's a 5th degree, my combinations are either 5 real, 1 real, 4 imaginary, because imaginary always has to be in pairs, or 3 real and 2 imaginary, which as soon as I see this takes up 2 already. So ideally, when you graph it, you should either see 3 that cross the x-axis, or you only see 1 time that it crosses the x-axis, and that would be at that positive 7, because this is the only real that they gave us. You're looking for the other set. So this is already 3 of your zeros used up. So it has to either be 2 more imaginaries or 2 more real where it crosses the x-axis. So I'm going to let you go do that one and see where it crosses the x-axis. But the total number of real zeros for this one is going to be 3 when you actually graph it, because 2 of them are already used up, and we have 5th degree, so that means there's 5 total zeros in solutions. All right. EOC release question. I think we've done this on 100 times, and hopefully we've gotten better. So 3 distinct zeros. So negative 1 at a multiplicity of 2. 2 at a multiplicity of 1. And then 4 at a multiplicity of 1 as well. So that means negative 1, which is going to be x plus 1 twice. It means it's going to bounce off the x-axis when you graph it. And then 2 one time. So it's going to be a negative 2. And then minus 4 because it's a positive 4. So multiplicity of 1. These 2 are going to cross your x-axis. These 2 are, this 1 at that positive 1, it's going to bounce off. So if you were to sketch this, positive 1, 2, 3, 4, positive 2, negative 1. So it means it's a 1, 2, so 4, and it does not say in the front. It's going to bounce at there. It's going to cross through at your 2 and cross through at your 4. If you plug this in, it should be 1, 2, 3, 4. 1, 2, 3, 4. Directional changes because there's 4 roots. All right, and then you're going to multiply it through. So x times x is x squared plus 1x plus 1x plus 1. So x squared plus 2x plus 1. So I've taken care of 2 of these. This one and this one. Moving down the line to use the next one, and I'm showing you this time with FOIL or distributive property. So first I'm going to do x times x squared, which is going to be x cubed, x times 2x, 2x squared, x times 1, 1x, and then I'm going to use negative 2 times x squared, which is a negative 2x squared. I like to stack them instead of just running long because I'll mess up positive, negative signs and mix up things. So negative 2 times a positive 2 is a negative 4x, and negative 2 times 1 is a negative 2. Then you can just combine these guys. So x cubed, these guys cross out, minus 3x minus 2. We've taken care of the second one. Not done yet. We got to do our x minus 4. So this whole times x minus 4. And so we're going to distribute our x all the way through. X to the 4th power. X times a negative 3x is a negative 3x squared. X times a negative 2 is a negative 2x. Then we're going to do our next one. They're negative 4. So that's getting negative 4 to the x to the 3rd power, which doesn't match any of my sets, so I'll just write it out here for right now. Negative 4 times 3x is going to be a positive 12x, and then negative 4 times 2 is 8. Now remember, your highest exponent goes in the front, so x to the 4th is our highest. Then we have minus 4x to the 3rd power, minus 3x squared, plus 10x plus 8. And that's your answer for that polynomial all the way through. It is a little bit of a commitment and a lot of work. When looking at the graph, 2x to the 3rd power minus 4x squared plus 13, the left side will go in which direction? Okay, so leading coefficient is positive, which means if I'm looking at this, it's going to be going up right here on the right-hand side. So it's going to finish going positive because the leading coefficient is positive. And then the degree is odd, which means it's going to be opposite on the other side. So it's going to be going down on the left and up on the right. And it has 3 directional changes, so obviously it's going to look something of some version of that kind of turn. So it's going to be down, up, So that's 1, 2, 3 directional changes because it's the degree of 3. It is odd, so that's why each end goes opposite, and the positive leading coefficient is why you know the right-hand side versus the left. The right-hand side is up, and the odd opposite means opposite of the end behavior. So the left side will be going in which direction, and that answer is down. What is the value of a positive root of the polynomial graph? So our roots would be here, here, here. So that's a positive 2, negative 1, and a negative 4. So the positive would be 2. It's the positive one. What are the roots of the polynomial? What are the roots of the polynomial? So the roots, these are factors. The roots mean to solve it. So I have x plus 3, x minus 2, and 3x plus 1. So I'm going to set them equal to 0 and solve all the way through. So I'm going to take my 3, move it over. So that's going to be a negative 3. My 2, move it over. That's going to be a positive 2. My 1, and now I'm going to have 3x equals a negative 1. Divide by 3 on both sides. So x equals a negative 1/3. So our third root would be a negative 1/3. So these are the roots or the zeros or the x-intercepts or the solutions. All the same thing. All right, so I'm going to pause this one and you're going to get a second video for the other half, guys. Hopefully this is starting to make some more sense.